The threshold of solving this problem lied only in this expression. We are asked to calculate the resistance of the wire. 0.9 ampere current when a 2 ohm resistor is used. V is I into R. Across the parallel, V is I into RP. Please do the simplification. Take your calculators. Do the simplification. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my today's session, my discussion will gravitate around the problems from the chapter Electric Current. Very, very important chapter. I have been calling this chapter as a master chapter. So it is very important that you concentrate. The last section of the question paper, problem number 34, is always allocated from this chapter. Again, as I told, simple concepts, simple equations, very easily you can solve problems from this chapter. So we start discussing the problems. The first one, the problem says a solid cube. There is a solid cube of metal of 0.01 meter. So a solid cube of metal of side 0.01 meter is drawn into a uniform wire 3 meters long. ಪ್ರಶ್ನೆ ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ. ಒಂದು ಸಾಲಿಡ್ ಕ್ಯೂಬ್ ಇದೆ. There is a solid cube which is modified as a uniform wire. ಒಂದು ಸಾಲಿಡ್ ಕ್ಯೂಬ್ ನ ಯೂನಿಫಾರ್ಮ್ ವೈರ್ ಆಗಿ ಮಾಡಿಫೈ ಮಾಡ್ತಾರೆ. Calculate the resistance of this wire. We are asked to calculate the resistance of the wire provided the resistivity is 50 into 10 power minus 8 ohm meter. Very simple. Here there is a solid cube, and this solid cube has side 0.01 meter. Therefore, first I'll write down the volume of the cube. Volume of the cube is 10 power minus 6 meter cube. The side is 0.01 meter. So the volume of the cube becomes 10 power minus 6 meter cube. Now, what is this modified as? It is modified as a uniform wire whose length is 3 meter. So, length of the wire is equal to 3 meter. What else is given? The resistivity of the material is given. Rho resistivity is 50 into 10 power minus 8 ohm meter. I have to calculate resistance of the wire. Very beautiful to understand. Volume of the wire should be equal to volume of the cube. Alva? The cube is getting modified as a uniform wire. Its volume has to remain the same. So, volume of the wire is equal to volume of the cube. I know the length of the wire. So, how do I express its volume in terms of length? Always remember, area into length will give you volume. So, volume of the wire, A into L, since length of the wire is known, so this is 10 power minus 6. So, A into 3 is 10 power minus 6, or A equals 10 power minus 6 by 3 meter square. So, very effectively, knowing few concepts, I have calculated the area, which is equal to 10 power minus 6 by 3. And remember, this is the area of the wire. With this, anywhere possibility to calculate the resistance of the wire? Sure. We know resistance is rho L divided by A. In terms of resistivity, resistance is rho L divided by A. So, R is 50 into 10 power minus 8 into 3 divided by 10 power minus 6 divided by 3. So, on simplification, the resistance turns out to be 4.5 ohms. So, students, very easily, keeping the concept of volume, calculating the area, and knowing the expression for resistance and resistivity, I have arrived at the resistance of the wire. Second one, something with respect to cell antakshna, EMF, internal resistance comes into picture. A cell supplies 0.9 ampere current through 2 ohm resistor. ಎರಡು ಕೇಸ್ಗಳಿದೆ ಇಲ್ಲಿ. There are 2 cases given in the problem. Cell supplies, in the first case, 0.9 ampere current when a 2 ohm resistor is used, and 0.3 ampere current when a 7 ohm resistor is used. I have to find the internal resistance of this cell. ತುಂಬಾ ಈಸಿ ಆಗಿರುವಂತ ಪ್ರಾಬ್ಲಮ್ ಇದು. Cell supplies 0.9 ampere current when the resistance is 2 ohms. So, in the first case, current is 0.9 ampere when the resistance is 2 ohms. How do I bring in the picture of internal resistance here? ಮತ್ ಪುನಃ ನೀವು ಬಹಳ ಕೇರ್ಫುಲ್ ಆಗಿ ಗಮನಿಸಬೇಕು. You should know the relation between current, EMF and internal resistance of a cell. So we know I equals E divided by R plus R. This is the basic expression for current in terms of EMF and internal resistance. You have to keep this in mind. I equals E divided by R plus small r. So this is I1, R1. On substituting, I1 is 0.9, E is not given, R is 2 plus small r, or E equals 0.9 2 plus r. I call this equation 1. Now similarly, in the next case, it is supplying a current of 0.3 ampere when the resistance now is 7 ohms. So, in the next case, I2 is 0.3 amps when the resistance is 7 ohms. Again, write down the basic formula. 100 times I have told. Question paper clear kottidare. Problem solved without writing the relevant formula shall not carry any marks. So again, I2 is E divided by R2 plus small r. Next ಏನಿದೆ? Substitute ಮಾಡಿ. 0.3 equals E divided by 7 plus r, or here E is 0.3 into 7 plus r, equation 2. Now, is there any great difficulty calculating r? Just compare equations 1 and 2. Simplify. R is 0.5 ohms. See, the threshold of solving this problem lied only in this expression. If you know that expression, substitution, simplification, and arriving at the result is very, very simple. Interesting one. A resistance of 9 ohms is connected to a cell. ಮತ್ ಪುನಃ 2 ಭಾಗಗಳಿದೆ ಪ್ರಶ್ನೆಯಲ್ಲಿ. Resistance of 9 ohms is connected to a cell. The voltmeter connected across the cell reads 1.8 volts. So there is a resistance of 9 ohms which is connected to a cell. Voltmeter across the cell reads 1.8 volts. So in the first problem, first case, here is a cell. So a resistance of 9 ohms. Now the voltmeter is reading 1.8 volts. This is the cell, students. Now what is that 1.8 volts? Voltage across the terminals of the cell. What did you call that as? Terminal potential difference. And what was the expression for terminal potential difference? We told V equals E into R divided by R plus R. Or in this case, 1.8 equals 9 or E into 9 divided by 9 plus small r. Now comes the interesting fact. When a resistance of 10 ohms is connected in series, resistance of 10 ohms is connected in series with 9 ohms. The voltmeter reading changes to 1.9 volts. Again ಮಾಡ್ತಿದ್ದೀವಿ second case ಅಲ್ಲಿ resistance of 10 ohms is connected in series with 9 ohms. The voltmeter reading changes to 1.9 volt. I have to calculate the EMF of the cell as well as internal resistance. So now in the second case, there is 10 ohm resistance which is connected in series, very clearly, in series with 9 ohms. Again, the cell, voltmeter. Now the voltmeter is reading 1.9 volts. When 10 ohms is connected in series with 9 ohms. Again, V is E into R divided by R plus R. Now V is 1.9 E into, now 10 and 9 ohms, they are in series. So this becomes 19. So 19 plus R. So therefore, I want the value of R and E. Divide equation 1 by equation 2. R turns out to be 1 ohm. Please do the simplification. Take your calculators. Do the simplification. R turns out to be 1 ohm. Substitute back in any other equation. E turns out to be 2 volts. So, very simple, students. We have arrived at the answer. Next one. Such problem I have already solved. So, this will be an assignment for you all. But again, I will help you to solve this problem. 3 resistors of 3 ohms, 4 ohms and 6 ohms are connected in parallel. Parallel combination kottidare. 3 ohms, 4 ohms and 6 ohms. So first, I will draw this circuit for this. So there are 3 resistors. So this is 3 ohms, 4 ohms and 6 ohms. Now, the combination is connected in series with a resistance of 1 ohm. Now further, this is connected in series with a resistance of 1 ohm and a cell of EMF 2 volts, internal resistance 2 ohms. I have to find the current through the resistances. So, EMF 2 volts, internal resistance 2 ohms. I is the main current flowing through this circuit. I1 across 3 ohm. I2 across 4 ohms, I3 across 6 ohms, I1, I2 and I3 has to be calculated. How do I do? As usual, first find the effective resistance for the parallel combination. So we have 1 by Rp, which is 1 by R1 plus 1 by R2 plus 1 by R3. Substitute 1 by 3 plus 1 by 4 plus 1 by 6. Rp will be the reciprocal of the sum. So many ohms. Next, this Rp is in series with 1 ohm. So Rs is equal to Rp plus 1, so many ohms. So I have found out the effective resistance in this part of the circuit. Now, current flowing through the circuit, main current. So I is E divided by R plus R. This is RS plus R, so many amperes. Very simple. First RP ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋದು, RS ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋದು. Basic expression for current, E divided by RS plus R, so many amperes. Now, potential across the parallel combination V is I into R, across the parallel V is I into RP. So, what is I1? V by R1. I2, V by R2. I3, V by R3, because for parallel combination, voltage always remains same. That's all. Next one. A 30 volt, 90 watt lamp is operated on 120 volt DC line. 30 volt, 90 watt lamp. It has to be operated on a feeder line of voltage 120 volt DC. For proper glow, what resistor should be connected in series with the lamp? Now, we know P is V square by R, which implies the resistance is V square by P. Basic definition of power, V square divided by R, or R is V square divided by P. Now, current flowing through the lamp, P is V into I, or I is P by V. If you observe, power is 90, voltage is 30. So 90 by 30, 3 amperes. What is the resistance now? I use this expression for resistance. So R is V square, 300 square divided by P. So, now what should be the additional resistance? So now I say I is V divided by R dash plus R. I is 3 amperes. V is known. R dash has to be calculated. If you simplify, R dash is 30 ohms. Again, very easily, using a few formulas, few concepts, I have arrived at the solutions. The next session, I will be working out few more problems from this chapter. Until then, have a nice time. Thank you.